transformations. So take notes on this. Okay. The first three transformations I'm going to talk about are of congruent figures. Okay, so transformations are ways that we move congruent figures to make patterns. Now, some of them we start very simply, so we're trying to look at them, and we don't want to, we don't move a lot of figures, we just do the basic movement to show you what it looks like. But when they make different patterns, especially tessellations that they do to cover the page, they're taking congruent figures and moving those in different ways. Okay, so the most basic transformation is called a translation. And a translation is basically if I take a triangle like this and I move it to a different spot on the paper. All I've done is I've moved it up so far and I moved it to the right. So in this translation, I've gone up to that area, and I've moved it over to here. So I've translated it up and over. You have to have specified amounts. Usually we do translations on graph paper, so we can say we translated it up so far and to the right so far. Okay, so that's one way of doing a translation. A transformation. You just translate it. You move it up. This is used a lot in graphing, and we're going to tie this into graphing when we come back from the break, because we can graph and we do translations with our functions. When we graph functions, okay, we do translations. We can actually find, or we can use transformations to get, so if I have y equals x squared, that's a basic function. We can translate that. We can flip it by reflecting it. So we can do a lot of things with transformations on graphing functions. And so we will do like just y equals 8x, that's the basic function. Y equals the base times of x. Okay, that's a basic function. So we have ways of translating those functions. Okay, and so those, and sometimes this could be 2x, this could be 3, it just depends. Okay, so those are things that we can do with functions. We translate them, but sometimes we translate geometric shapes. Specifically, if you're making a pattern, a lot of times what ends up happening is you will translate it so that it fits in there. Okay, so a translation is just moving. They don't change the rotation or the setting. You just move it either up, down, left, right, all those. That's a translation. You're translating it somewhere else. It's word for word. It's identical, except for where it's on the paper. Okay. So we'll tie it in. This is part of the advanced algebra part, is we're going to tie it into these graphs. One of the ones that's really easy to see is the y equals x absolute value function. You can see how the translation works with that one. So we'll be working with those functions just to see how they were transformed, and you get these new functions. Okay. The next one is a rotation. Well, no, let's go to the reflection first. You've been working with reflections a lot already. we call them lines of symmetry, or we have talked about, well, because we reflect over lines of symmetry, okay? But you can reflect the whole image over a line, okay? So it could be lines of symmetry, or it could be the entire image reflected over a line, okay? So let's say that I have this parallelogram that looks kind of like that, and I'm reflecting it over this line, okay? What would that look like if I reflected it over? So I'm going to come up and try to draw it, show me the reflection. Reflecting it over that line, how would it look? How do we remember, how did we find lines of symmetry? What did we do with our paper?
Folded it.
You fold it in half, okay? And you look for where does it match up when I fold it in half. So reflection is always when I can lump it over, yes.
You just put the point that's going into the line on the other side and you draw it.
Like this?
Yeah.
Yep. And I'm terrible at this kind of thing, but okay. It's gonna be somewhat like that, because it's when I fold the paper. So a line of reflection is where I can fold it. This is actually taking the entire image, not just part of the image. So we looked a lot at reflections or lines of symmetry for all of the different trapezoids, the quadrilaterals that we had, rhombuses, rectangles, squares, and we looked for all those lines of symmetry, where it could be reflected. And we talked about reflection over lines. On some of the problems you had to ask, is it a reflection over a line? You did this with letters, okay, or with different shapes. You look to see if does it reflect over a line or does it reflect over a point. Okay. A reflection over a point or in a direction around a point is actually called a rotation. Okay. So a rotation is basically when the image is rotated around a point, okay? It's also a lot of times called a point symmetry. That's, so if I did this, okay, that is not a perfect reflection, because if I flip it over like that, it will not land on there. But if I rotate it basically around this point in the middle, if I rotate it around, I actually have a point of rotation. So you're rotating it like 180 degrees or 90 degrees or something. So I could rotate this one, it could be a P like this. I could also have a P, kind of like that. You rotated it just basically 90 degrees there, okay? So there's different ways to rotate. Usually we rotate 90, 180, 270, those kind of things. But you can find where they rotate them 45 and stuff like that. So that's called a rotation. So there's translations. These are all in the category of transformations. Transformation is when these are congruent figures. You're moving them into different ways to make patterns. Okay. So that's what you're looking at there. So we're gonna, when we make your tessellation, we're gonna look at some tessellations today, and that's why I was gonna have you bring your computer so you could look at the tessellations, and you're trying to find out from those tessellations what are the types of transformations that have been used to make those patterns. Okay, so that's what you'll be looking at, because it's kind of interesting to see how some things come out and what they are. Okay. Now, there's one more transformation, but it does not keep the figure congruent. This is more used in the infinite series. Okay, so this is the last transformation that we have. And it's actually called a dilation. But it does not keep the figures are not congruent. The figures are not congruent, but are similar. Okay, in a dilation, the figures are not congruent, but they are similar. Does anybody know what that means? Yes.
Doesn't it usually mean the same shape but like a different size?
Yes, it's like a same shape. So if I'm just doing a nice old little square that I can't probably do very well, and I just take that square and I make it smaller, that's a dilation, okay? It's kind of like a scale image, a scale drawing of something. We can't make the entire house plan because it would be very, very big if we were to try to do that to scale. So we do a dilation of that. Everything's similar because all the angles stay the same, okay? The shape with the angles stay the same, and the sides are in a ratio. When we draw a ratio. So when we draw like house plans or any kind of plans usually, we do 1/4 inch is equal to 1 foot. So for everything, it's in that ratio. The ratio is 1/4 inch on the paper actually is 1 foot of true drawing. So that makes it go way smaller because 1/4 inch is not close to a foot. Okay, 1/4 inch is this little big, and a foot's this big, so you're making it very much smaller. Dilation's going to be either making it bigger or making it smaller. Okay, we do this with your photos. When do you do that with photos? How do you do it? Do you make them smaller or make them bigger? At times. What is that? I saw it. We go like how on our photos? Right? You ever done that? What does that do with your photo? It zooms in. Is it the same shapes and everything except for just at a different size?
Yeah.
Okay. Dilations are really just changing the size. Okay. You're just changing the size. Okay. These are the things that are true. The angles stay the same and the sides are in the same ratio, but we do this all the time with pictures. You print an 8x10. It's the same picture as a 4x6. It's just that it's zoomed in more. We can see the things bigger. Okay, they're bigger. Sometimes though, what happens is you don't have enough pixels in there because you have a lot of little squares, and if it's pixelated, it becomes more blurry when you zoom in. Okay, so that's why better cameras make better pictures when you blow them up or make them bigger. Okay, so those are the different types of transformations, and we're going to start by looking at some in the book, and then we're going to look at some tessellations, okay, that you've done. So we're going to start with that, and then we'll go through